Okay, so, when you're getting ready for those senior software engineer interviews,
Uh-huh.
it's not enough to just, be able to write out the code.
Right.
You really got to show that you understand the, deeper stuff.
Absolutely.
And one of the things that always seems to come up is nested classes in Java.
Yeah, for sure.
And I think for a lot of people, it's one of those topics where they're like, yeah, I kind of remember what they are,
Mm-hmm.
but they haven't really, thought about them deeply.
Right, exactly.
So today we're doing a deep dive on nested classes.
It's a great topic.
And with us, we have an expert on Java.
Well, I wouldn't say expert, but definitely spent some time with them.
Have you used nested classes in your own work?
Oh, yeah, definitely. They're super useful.
So we're going to try and get into when to use them, why to use them,
Exactly.
what are the different types, and all that good stuff.
All those little nuances that'll impress those interviewers.
That's right. So let's just dive right in. When we talk about nested classes, I guess the first thing is what even are they?
Well, at the most basic level, it's just what it sounds like. It's a class defined inside another class.
Okay, so literally a class within a class.
Exactly.
Got it. And why would you do that? I mean, what's the point?
Good question. There are actually a couple of really good reasons. It can help you organize your code better,
Okay.
keep things tidy. Like when you have classes that are very closely related to each other, it just makes sense to put them together.
Uh-huh.
The classic example is like an invoice class, right?
Okay.
And then inside that, you might have a nested class called item because each invoice has multiple items.
That makes sense, just conceptually.
Right, exactly. It just makes your code more readable and understandable.
Okay, so it's like a way of grouping things that belong together.
Yeah.
Got it.
And then another big reason is control. You get more fine-grained control over visibility and access.
What do you mean by that?
Okay, so you know how we use public, private, and all that to control access to methods and fields within a class?
Right. Yeah.
Well, nested classes add another layer to that. You can make a nested class private, for example, which means it can only be accessed from within its outer class.
Oh, I see.
That's like saying, this little class here is only for internal use within this bigger class.
That makes sense.
It can really help you encapsulate things properly and prevent accidental misuse from other parts of your code.
So even more encapsulation than just using private methods and stuff.
Exactly. It's encapsulation at the class level.
Nice. So we've got organization and access control.
Right.
Anything else?
Well, those are the main reasons, but there are some other nice benefits too. Like, for example, sometimes using nested classes can actually make your code shorter and more concise because you don't have to repeat certain things.
Okay, we'll have to get into that.
We can definitely explore that with some examples.
Cool. So it sounds like there's more to nested classes than meets the eye.
Oh, absolutely. And what's really interesting? There are actually two main types of nested classes, static and inner.
Ah, okay. So it's not just one thing.
Nope. And this is where it gets a bit more complex and also more relevant for those tough interview questions.
Yeah, I bet. So what's the difference between these static nested classes and inner classes?
Well, the key difference boils down to one thing: whether or not the nested class has access to the instance of its outer class.
Okay, break that down for me a little bit.
Sure. So with static nested classes, it's kind of like they're just hanging out inside the outer class for organizational purposes. They don't have any special connection to a particular instance of the outer class.
So it's even if you create multiple objects of the outer class, the static nested class is just kind of shared by all of them.
Exactly. It's like a blueprint that's associated with the outer class, but not tied to any specific object of that class.
I think I'm starting to get it.
Good. Now, inner classes are different. They do have a special connection to the outer class instance that created them.
Each inner class object knows which outer class object it came from.
Precisely. It's like a little buddy that's always hanging out with its big buddy, and this buddy system has some pretty interesting consequences.
This is making me think of those little Russian dolls that fit inside each other.
That's a great analogy. Each inner class doll is nestled inside its outer class doll, and they always come as a pair.
Right. Okay, so I'm starting to see the difference here, but I bet there are some tricky details.
Oh, yeah. There are definitely some things to watch out for. That's why we're going to go through lots of examples and really break it all down.
Awesome. So let's start with static nested classes. Can you give me a concrete example of how you might use one?
Sure. Let's go back to our invoice and item example.
Okay.
So you have your invoice class, and inside it, you define a nested class called item.
Right.
Now, if you declare this as private static class item, you're saying a few things. First, it's private, which means it can only be accessed from within the invoice class itself. So no other part of your program can mess with it directly. And second, it's static, which means it doesn't need a specific invoice object to exist. It's just associated with the invoice class as a whole.
So why would you want to make it private?
Well, it goes back to that idea of encapsulation. You're basically saying this item class is only meant to be used internally by the invoice class.
I see.
It helps keep things tidy and prevents other parts of your code from depending on the internal details of how invoice works.
Right. It's like hiding the implementation details.
Exactly. And because of that, you often don't even need to make the fields within the item class private.
Oh, interesting. Because the only thing that's ever going to touch those fields is the invoice class itself.
Precisely. So you can simplify the item class quite a bit.
Okay, so private static is like a way of saying this nested class is just a helper for my outer class, and nobody else needs to know about it.
Exactly. That's a perfect way to put it.
But what if you do want other parts of your code to be able to use the nest class?
Well, then you can make it public static. And in that case, it's a lot like a regular top-level class, except still nested inside the outer class for organizational purposes.
So how would you create an instance of a public static nested class from outside the outer class?
You just use the fully qualified name. So if your outer class is invoice and your nested class is item, you'd write something like invoice, item, my item, new invoice, dot item, widget 10, 9.99.
Okay, so you have to specify the outer class name as well.
Exactly. It's like saying, I want the item class that's specifically associated with the invoice class.
Got it. So a public static nested class is kind of like a regular class, but the nesting gives you that organizational benefit.
Right. It immediately tells anyone reading your code that this nested class is somehow related to the outer class.
Like it wouldn't make sense to have an item class nested inside a car class, for example.
Exactly. The nesting just makes it obvious what the purpose of the nested class is.
Okay, so we've got static nested classes down. Now, what about these mysterious inner classes?
Yes, inner classes. This is where things get a bit more interesting, shall we say.
I'm ready for it. Hit me with an example.
All right. Let's imagine we're building a simple social network.
Okay.
So you have a network class that represents the whole network.
Got it.
And then you have a member class that represents each individual user on the network.
Makes sense.
Now, in this case, it makes a lot of sense to nest the member class inside the network class.
Right, because each member belongs to a specific network.
Exactly. But here's the key difference. This time, we're not going to use the static keyword. We'll just declare it as class member inside the network class.
Okay, so it's a non-static nested class, which I guess is why we call it an inner class.
Precisely. And by dropping that static keyword, we're creating a very special relationship between network and member arc.
What kind of relationship?
Well, now each member object will have an implicit reference to the network object that created it.
Wait, really? So like it remembers where it came from?
Exactly. It's like it has a little invisible string tied to its parent network object.
That's so cool, but also kind of weird.
Yeah, it can be a bit mind-bending at first. But once you understand how it works, it opens up a lot of possibilities.
Okay, I'm intrigued. Can you give me an example of what you can do with this like parent-child relationship?
Sure. Let's say your network class has a method called enroll that takes a member's name and adds them to the network.
Okay.
Inside that enroll method, you create a new member object using new member name, right?
Right.
Well, because member is an inner class, that new member object automatically gets associated with the specific network object on which the enroll method was called.
So if I have two different network objects, my network and your network, and I call my network.enroll Alice, the new member object for Alice will be specifically linked to my network.
Exactly. And if you then call your network.enroll Bob, the new member object for Bob will be linked to your network.
Got it. So it's like each member is tagged with the network it came from.
Right. And this tagging is what gives inner classes their power. Because now, from within any method of the member class, you can directly access the members of its parent network object.
Whoa, really? Can you show me examples?
Sure. Let's say our member class has a method called deactivate.
Okay.
And inside that method, we want to remove the member from the network's list of members.
There.
So we could write something like members.remove this.
Wait, hold on. Members is a field of the network class, right?
Right. It's like a list that the network object keeps track of all its members.
But how can we access that from inside the member class?
That's the magic of inner classes. Because the member object has that implicit link to its parent network, it can directly access the members field of that network object.
So it's like the compiler automatically knows which network object we're talking about.
Exactly. It's like saying, hey, member object, you know where you came from, right? So go ahead and remove yourself from the list of members in your parent network.
That's pretty amazing.
Yeah.
So inner classes give us this direct line of communication between the inner object and its outer object.
Precisely. And this can be incredibly useful for certain kinds of tasks.
Yeah, I can see how that would be handy.
Yeah.
But it also feels kind of like dangerous.
How so?
Well, if the inner class can just mess around with the outer class's data directly, couldn't that lead to some, like, unintended consequences?
That's a valid concern, and it's definitely something to be aware of when you're designing with inner classes.
So, like, it's a powerful tool, but you have to use it carefully.
Exactly. Inner classes create a very tight coupling between the nested class and the outer class, which can be great if that's what you want, but it also means they're less flexible and reusable in other contexts.
Right, because they're so dependent on that specific outer class.
Precisely. So, as with any powerful tool in programming, the key is to understand its strengths and weaknesses and use it wisely.
Okay, so I'm starting to wrap my head around inner classes. But what about the syntax? Is it the same as with static nested classes?
Well, there are some differences. Remember how with static nested classes, we could just use the fully qualified name to create an instance? Like invoice.item, my item, new invoice.item. We can't do that with inner classes. Because an inner class needs an instance of the outer class to exist, we have to create it from that outer class instance.
Okay. So how does that work?
It's a bit more involved. Let's say you have a network object called myNetwork, and you want to create a new member object associated with it. You'd write something like this: network member new member, mynetwork.newMember, Alice.
Okay, so we're using the new keyword on the myNetwork object itself.
Exactly. We're saying create a new member object and make sure it's linked to this specific network object, myNetwork.
Got it. So the syntax reflects the fact that inner class objects are always tied to a particular outer class instance.
Precisely. And there's one more syntax thing that often trips people up. Remember that implicit link to the outer class that inner classes have?
Yeah, like that invisible string.
Right. Well, sometimes you need to be explicit about referring to the outer class instance from within the inner class.
What would that be?
Let's say you have a method in your member class called belongs_to, which takes a network object as an argument and checks if this member belongs to that network.
Okay.
You might be tempted to write something like return this at network.
Right, to see if the current member object is equal to the given network object.
But that won't work, because in this context, this refers to the member object itself, not the outer network object.
Ah, I see the problem.
So to explicitly refer to the outer class instance, you have to use a special syntax. OuterClass.this. In our case, it would be network.this.
So the correct code for belongs to would be return network, this network.
Exactly. That network, this, is basically saying, give me the reference to the specific network object that this member is associated with.
Got it. So it's like a way of saying, I know I'm an inner class and I want to talk to my parent.
That's a great way to think about it.
Okay, so we've covered a lot of ground here. We've talked about static nested classes, inner classes, the syntax for creating them, the special relationship between inner classes and their outer classes, and even some of the potential pitfalls to watch out for.
Yeah, we've gone pretty deep.
But I think it's been really helpful. At least for me, it's definitely cleared a lot of confusion I had about nested classes.
I'm glad to hear that.
So to wrap things up, maybe we can just do a quick recap of the key differences between static nested classes and inner classes and when you might choose to use one over the other.
Sure, that's a great idea. So the fundamental distinction is that inner classes have that special connection to their outer class instance, while static nested classes do not.
Right, that invisible string.
Exactly. And this difference has a big impact on how you use them. Static nested classes are great for organization and controlling visibility. They're like little helper classes that are closely associated with the outer class, but don't need access to its instance-specific data.
So if you just need a way to group related functionality or restrict access to a class, static nested classes are the way to go.
Right. Think of them like utility classes that are scoped to the outer class.
Makes sense.
Now, inner classes are all about that close relationship with the outer class instance. Use them when your nested class needs to directly access the outer class's fields and methods.
So if you need the nested class to be able to manipulate the outer class's state, inner classes are the way to go.
Exactly. They're perfect for things like event listeners, adapters, and other situations where you need that tight integration between the inner object and the outer object.
Awesome. So to sum it all up, Nested classes are a powerful tool in Java that can help you write more organized, encapsulated, and efficient code.
And understanding the nuances of when and how to use both static and inner classes is a key skill for any senior Java developer.
Absolutely. And I think this deep dive has given everyone a solid foundation to build on. So for all you aspiring senior engineers out there, I encourage you to keep exploring nested classes and experimenting with them in your own projects.
And as you do, consider this. How do the choices you make about using static versus inner classes impact the overall design of your software? Do they make your code more coupled or less coupled? More flexible or less flexible? Thinking about these trade-offs is what separates good developers from great developers.
That's a great point to end on. Thanks for joining us for this deep dive on nested classes.
It was my pleasure.
And for all our listeners, keep learning, keep coding, and keep pushing yourselves to become better engineers every day.
Couldn't have said it better myself.